I think it's unfair, but it is what it is. If it was just me assigning problems out of the book, and you reference the solutions manual, it'd still be different.
And you're also going to post that take-home?
I will post the take-home this afternoon. All right, so here we go. We have our exponential equation. Okay, this is where you really earn your money. I'm certainly not going to get a common base, right? So I'm going to take a log of both sides. And me, I like taking natural log of both sides because natural log is only 2 letters, and common log is 3 letters, and I'm just that lazy. Okay? Otherwise, I could take common log. It wouldn't make a difference. Alright, now what was the point of taking the log of both sides? What does that let me do now? I can bring my exponents out in front of the log, right? So the 4x plus 1 in parentheses times the natural log of 7 equals the 2 minus x in parentheses times the natural log of 4. And that looks scary, doesn't it? It's not. You know how to solve that problem. If I had hypothetically said, what is 8 times, I don't know, 4x plus 1 equals, say, 3 times 2 minus x. Is there anyone that does not believe they know how to solve this equation? Okay? I argue that that equation is structurally the same thing as this equation. I've got a number times 4x plus 1 in parentheses. Over here I've got a number times 2x minus 2 minus x in parentheses. This natural log of 4, as ugly as it is, it's just a number. I don't really know what that number is. Well, I do. It's that 1.3 whatever that I saw earlier. But it's just a number. And I don't want to have to write out all 12 digits of that number, so I just keep calling it the natural log of 4. But that's all it is. It's just a number. Ditto here for the natural log of 7. The natural log of 7 is going to be 1 point something or another, maybe 2 point something or another. Probably 1 point something or another. No, I don't know. I don't care. But it's some number. Okay? It's a number times this in parentheses equals a number times this in parentheses. If you were solving this equation, what would you do? You would distribute to get rid of those parentheses. That's what we're going to have to do here. I'm going to have to distribute my natural log of 7. So 4x times the natural log of 7 plus 1 times the natural log of 7 is just the natural log of 7 equals, on the other side, distribute. 2 times the natural log of 4 minus x times the natural log of 4. I know that looks gruesome, but once again, we have solved this equation before. We did it about the 3rd week. About the 3rd week of class, we started solving things like this. Do y'all remember doing that? And if I said solve for x, what would you do? You would start by getting your x stuff together, right? And you get rid of everything else that doesn't have an x. Same thing here. If I want to solve for x, I've got an x here, and I've got an x here. I want to get those guys on the same side of the equation at least. Okay? When we did it over here, and we subtracted off the 4x, we made the argument that these guys were not really like terms then. They don't really combine nicely, right? Same thing here. I'm going to add this guy over. I'm going to have 4x times the natural log of 7 plus x times the natural log of 4. Okay, they both have an x, but they're not really nice enough terms that combine super nicely. Okay? Do y'all buy that? Yeah. Okay? So this is going to equal, well, what's left on the other side? 2 times the natural log of 4, which, if you're smart, you could call that the natural log of 16. That's the same thing as 4 squared, right? Or you can leave it as 2 times the natural log of 4 in your calculator. I'll take care of it for you later. It's fine either way. What else do I have left though? Minus this log of 7 that we moved over to the other side. I didn't really want to bring this up, but I'm of two minds about this. There's one camp of you that think, if my calculator does all that arithmetic for me, then I'm just going to let the calculator do that. But there's another camp of you that I think would benefit by using the properties and cleaning this up. If I brought that 2 up and called that the natural log of 16, and that's the natural log of 16 minus the natural log of 7, and I can combine those as a single logarithm too. And I don't know that that wouldn't necessarily be better. Alright, so here's what we're going to do. We're going to do it both ways. You can either leave it like that if you think that's a good idea, or you can call it the natural log of 16 over 7 if you think that's better. Okay, so back to the left-hand side. On this problem, we had the by minus the 3y. What was the next step here to solve for x? If I couldn't combine them, what could I do? Factor it out, kind of like sort of unmultiply, sort of divide it out. Guess what? We're going to do the same thing here. If these guys don't combine nicely, I can at least pull an x out of here, right? So this is going to be x times 4 times the natural log of 7, which again, you can clean up if you really, really wanted to, plus the natural log of 4, which could clean up if you really, really wanted to, equals whichever one you picked. I'm going to go with the 2 times the natural log of 4 and all that. If you're committed to calling that the natural log of 16 over 7, good. Go for it. I know it's gory, bloody, gruesome, seasonal, but right here, what does this really say? This says x times a number. That's all this is. This is all just a number. 4 times the natural log of 7 plus the natural log of 4. If you type that in, that's just a number. And how do I get rid of multiplying by a number? I divide by that number. So I'm going to divide both sides by 4. That's the natural log of 4.
If you was to clean up the other side, like you did the 16 over 7, what would your cleanup be?
Let's see, 7 to the 4th power is 2,401. And 2,401 times 2 is, I think, 9,600 and...
You still just multiply them?
Yeah. Yeah, I think this works out to be the natural log of 16 over 7 divided by the natural log of 9,608. So that's me doing it in my head, so I'm not positive about that number. No. 4. Still a question mark. Y'all have calculators? Somebody tell me. What's 2,401?
9,604.
What?
9,604.
4? Okay.
Did I do 2 or 4? 2,401 times, yes, it's 9,604.
Okay. So, my argument is these two guys are the same. If you plug this in the calculator with the parentheses around your numerator and the parentheses around your denominator like you're supposed to, you get your solution. If you plug it in like that, you get the same solution.
What are you doing? Insert in the calculator if you miss something?
To insert something, you hit second delete, INS.